Good morning. Thank you for being here today. We really appreciate your time and interest in our presentation. I'm excited to kick things off and introduce our presenter and co-founder of New Era Software, Paul Robichaux. Paul, why don't you go ahead and take it away?
Okay, Sammy, thank you so much. I want to second Sammy's appreciation for your attendance today and also for your support of New Era and its products over the last 25 to 30 years now at this point. Today, we're going to talk about List Directed IPL, a new feature that became available in ZOS 3.1. It's comparable to something you probably already heard about or maybe even experienced in Linux or Windows or UNIX environments. It's often referred to as secure boot. Essentially, it's a functionality that allows the operating system to validate the integrity of its components at the point at which a system initialization is taking place. That kind of feature hasn't been available in the ZOS environment up until 3.1, and it's a critically important part of assuring the provenance, if you would, of the operating system and all of its components. When we look at it from a big picture perspective, it probably becomes clearer that the ZOS supply chain is, if you would, divided into a number of different steps and components and the delivery of components to the chain from various different locations around the world. But as those components are being delivered, their integrity is being validated using a number of different methods so that each of the receiving steps within the supply chain can validate its source and assure that it's coming from some place that is reliable. This all works good until we finally get to the last mile, where typically those components enter what is sometimes referred to as a clean room, a place where you will perform certain customization and modernization steps that are specific to your organizational needs. It's in this last mile, if you would, that potential for disruption or perhaps for malfeasance is sometimes assumed to take place. The whole purpose of a list-directed IPL is to harden that step, to make that clean room, if you would, an environment that we could think of as a zero trust environment, where only individuals who have the need to and the right to make those modifications are actually doing their work. And then as that work progresses, those components that they're modifying are signed and can be attributed to them and their work before they are passed on to a production system to be IPL'd using a new component of ZOS 3.1 called the ZBoot loader. So the whole idea here is to harden the supply chain, to be able to provide attribution and provenance to all of the components that will be used in an IPL, the thousands of components that will be used, and to eliminate any possibility that some malfeasance is interjected into one of those components, and to allow the operating system to actually perform those steps of validation that would identify them and report them, either in the form of an audit report or perhaps in the form of a wait state, depending on the level of and requirement that you place on the operating system itself. Now, in order to accomplish this, once the clean room is established and the policies are in place to ensure that only a limited number of authorized individuals have access to it, the next thing that has to happen is that we have to build the structures that are necessary for the validation process to take place. And this is a number of different steps. Sometimes people will hear me refer to it as the anatomy of a list-directed IPL because it important to realize that all of these components are linked one to the other. So the first thing that's going to have to happen is we're going to have a user who's going to have RACF special authority, because in order to build these components, we're going to need to be able to not only create key rings and certificates, but also create the profiles that are associated with each, whether they are in the facilities class or the RDataLib class, and then permit individuals, particularly signers, to use those components as they perform their work and prepare packages, if you would, the nucleus, LPA modules, sysres volume, for use in an IPL. Now, in order to accomplish that and to make it less cumbersome, New Era created a tool called ValBoot. And ValBoot's processes and services are such that it can help you to build and test, export and audit, maintain, review, and monitor all of these structures and components over time. It's not appropriate to think of these processes as a one and done kind of activity. Users will change, requirements will change, certificates will expire, any number of things may happen that will recall or cause a need for maintenance and support of the structures themselves. Once the structures are in place, then a signing activity takes place using one of two IBM supplied components, ICK DSF, which I'm sure you're quite familiar with, will be used to sign the volumes and the IPL text that's on the sysres volume. IEW sign, a new component in 3.1, will be used to sign the load libraries themselves. So once those signings have taken place, the certificate that was used in the signings is then exported to the HMC to apply the resources in a secure boot. In those certificates, there is a fingerprint, and that fingerprint is loaded into the HMC and becomes a validation point for continued use of those components in an IPL, as that certificate, that fingerprint is distributed to the number of LPARs that are in the sysplex, either locally or remote. All of the components are pack-to-pack copied over to the target CAC that will be used to distribute them. And then a component called the ZBoot loader is then used to load those components into the IPL process, including the validation of the sysres volume and its IPL text, and the load modules that have been signed, again, in the nucleus and LPA and others over time. The findings that are associated with the IPL themselves may result in a go, no-go kind of situation. If the components, that is the sysres volume and the related modules, do validate, that is, the operating system says, yes, these are signed with the appropriate certificate as exported to the HMC, then the IPL is a go. If the signing does not validate, then it's a no-go situation, and you have a choice at that point either to continue with an audit report being created or to enter a wait state. Now, for years, ImageFocus has performed a simulated IPL of the IPL process itself so that you could validate your work and make sure that it was appropriate for an attempted production IPL. In the current release of ImageFocus, there is an option which allows you to perform the same type of simulation for an LD-IPL, and we call it the secure boot option. What it will do is it will look at the IPL text on the IPL volume as discovered from the unit address as provided to it, check to make sure that system class or storage class memory has been defined in IEACs, a critical, important part of the overall process. Check the signing of the nucleus and the various LPA components, PLPA, FLPA, MLPA, and DLPA. If all of that passes, that is, this image focus says, yes, all of these are signed appropriately, then its normal processes would be such that it would end with success. If it finds that any of them do not validate, then it will detail its findings as part of its overall image inspection report. So again, at the big picture level, this is an attempt to ensure that the supply chain, particularly that last mile when you get involved in actually updating the components that are delivered to you by IBM, are validated with a method that allows the final step, which is the IPL of those components into a production system, to be perform that validation by the operating system itself. In order to do that, we need to build some structures. Those structures need to be moved into a production environment, particularly that fingerprint into the HMC, and then that certificate information is used to validate the individual components. Now, it's not a simple process. The structures that we build, and you'll see them being built in validated boot here in just a moment, are stored in the RACF data store. And so those components, that key rings and certificates, profiles, and permits, once built, are all there in RACF. So when we attempt, for example, the signing of load libraries, the signing process itself will take place using an application provided by IBM referred to as IEW Sign. IEW Sign has 3 different operational modes. It can operate to sign load modules, it can operate to unsign them, and it can operate to create reports that I think of as audit reports of the signing activity itself. Now, importantly, what happens when you execute IEW Sign is in its first step, it calls a service that is provided by RACF that's referred to as rpigum sign ver. That callable service will begin a process of attempting to discover whether the individual who submitted the job actually has a facility class profile that gives it the necessary authority to complete the signing process itself. Now, there are several different ways in which that facility class profile can be constructed. But once it is found, it is, if there is one and it can be found, then that profile in turn will be interrogated to extract the key ring that contains the certificate that will be used in the signing process itself. This is not for the faint of heart. There are a number of different steps here. Again, the anatomy analogy comes into mind. That needs to be followed very strictly and needs to be understood clearly, because if failures occur, it becomes quite frustrating to be able to diagnose them and to correct them accordingly. So we hope that ValBoot will help to ease that strain and move you on to a quicker implementation of this process itself. The same thing is true when we design a volume. Instead of IEW sign, we use ICK DSF. But it in turn, if it is structured accordingly and has available to it, as you can see down here at the bottom, a reformat form which says LD-IPL standard, we'll make a call again to that service to determine whether or not the user who is submitting the job has the appropriate authority to do that and to complete the signing successfully. The steps will be the same. There'll be an interrogation of the facility class profiles to see if there can be a match. If there's a match, Then the APPL data component of that profile will be extracted to determine if there is a key ring that matches. If there is a key ring, then a certificate will be extracted and used in the signing of the IPL text itself. Now, one major difference in the way in which these signing processes take place is that when we're signing modules and components, the key element, as I mentioned earlier, will be the certificate fingerprint that will be passed to the HMC. That fingerprint also appears in all of the individual modules, so that can be validated appropriately. But it does not appear when the IPL text is signed. Instead of the fingerprint, another component of a certificate is embedded in the signing of the, excuse me, the sysres volume, which is referred to as a subject key ID. And that subject key ID is now involved on the IPL track as a PKDS7 package. And so there is now some additional sophistication, if you would, that differentiates the way in which the resulting signings actually appear in the structures themselves or in the components themselves. Modules use fingerprints, volumes instead use subject key IDs. So there's a difference there, and if you get into the details of it, it's important to understand that those distinctions. So Valboot is designed to interactively test and build and validate and manage this whole process. On the other hand, Image Focus and its application, Secure Boot Audit Report, is designed to execute in conjunction with a normal image inspection, a simulation, if you would, and in that process, to determine whether those structures still maintain their structural integrity. And so the two of them are closely related together. In one case, we build and validate the structures and apply them, and then step into the background as the processes continue over time. Image Focus continuously monitoring those structures to make sure that in the next attempt at IPL, that those structures in fact are in place and still valid. So I'm going to go ahead and stop this now, and then we'll have a look at this in detail so you can get an idea of how this all works. So let me go ahead and share a different screen here. Okay, so this is a normal 3270 environment. I have two environments actually set up here. This is TSO, ISPF you're looking at here. This, on the other hand, is a VTAM application that is an interface to Image Focus in the control editor. And we'll bounce back and forth between those two, but I like the TSO environment because it seems to be the one that most people would be using in the process of creating the signing structures in the clean room itself. This operation under TSO is usable from the TSO command line in place in TSO. And so in order to reach the validated boot application, all you need to do is type TSO $CLI command line interface, comma, asterisk val boot. And I'm an admin, and I'll show you why that's important here in just a moment. So this is the primary menu for Valboot. This gives us access to functionality that can allow us to build the various structures that are necessary, key rings, certificates, permits, all of that stuff. But before we do that, let me just spend just a moment showing you some of the management tools that are available within the Valboot environment. Now, one that's really important is that if you are an admin, you have the ability to actually assign roles. And so there are three different levels within the Valboot environment. You can be an administrator, you could be a signer, and you could be an auditor. And each one of these has its own unique interface of both allowing and in some cases limiting access to certain functionality. Within each one of these, there is any number of different processes, if you would, displays that can give additional information. For example, this is a list display that's showing this profile and in a native RACF form so that you could, if you wanted to, just simply validate what you're seeing on the screen. There are, of course, other mechanisms here that allow you to permit other individuals to the functionality if you chose to want to do that. There is a history that's being maintained of all the interactions that are occurring that are being maintained in the ICE control journals that are supported by the control editor. And you can see some of the entries that I made earlier this morning as I was attempting to make sure that everything was working as I expected. As we post those things, all the details associated with those postings are incorporated into the control journal and they become an inviolate record of the activities of signing both volumes and modules, and any exports or renewals that are made of any of the certificates that are associated with the process itself are all captured. So this becomes an audit trail, if you would, of activities that are associated with the signing processes themselves. Importantly, and we'll come back and use this in just a minute, is a list of all of the available structures that can be accessed and used in signing so that we get a chance to validate each one of these as we go forward in time. There are a number of different ways I mentioned earlier that the structures themselves can be set up. And we see that the basic differentiation in the structure is the way in which the key ring is defined and the way that trickles down, if you would, into the facility class profile itself that is used to protect that key ring. Our best method, our best practice, is to have an individual key ring for each individual signer. What that would wind up translating into is that each user that is permitted to sign would then assume responsibility for the resources that are passed forward to a production HMC. That we believe is the best method that should be put in place, the best practice. That allows for the attribution of any issues that are associated with that particular signing process and ultimately the List Directed IPL to be traced back to a specific user. If I was a systems programmer with responsibility for a specific KEC, I would want this kind of process in place so that it was clear that if there was success, it was mine. If there was a failure, that was on my shoulders, and I had to do something about it in order to take care of it. So we believe this is the best method. It's not the only method, but any other method that might link a user to a group or to some general process itself will lack the ability to be able to track the individual user back to a specific signing process itself. So we think this one's the best, and it's the one that we recommend and use, although others are appropriate if you decide to use them. There are other components here that we'll come back and test in just a minute. We can audit the signing of a sysres volume or load libraries by name. Let me go back to the primary panel and we'll begin to build some components themselves. The first thing we might want to do is clear up an existing key ring, so we can list all the key rings that are out there. I have one out here now for Jim Lautner, my good friend and colleague, and I'm going to go ahead and delete that. We can do a number of things with it. We can list the details, look at the profiles, but we'll go ahead and delete this key ring and rebuild it. So we'll confirm that action. We always have a trace turned on. In some cases, it's optional, but by default, it is turned on. You can turn it off if you want to. That traces all the steps that we've taken in order to accomplish a specific task. And so you can see here that we're deleting the key ring, we're deleting the profiles, and we're checking to see whether or not there is any reply from RACF when we actually go through a rack list refresh. It's possible that there will be a reply and a refresh if we are in a sysplex environment. I happen to be on a ZPDT, single system, no sysplex, and so in those cases, there is no reply received back from RACF when we do a refresh. When I PF3 back, we can see now that that key ring has been deleted. Now, when I come out to my panel again, and now I go and look at the certificates, we know for a fact that if we delete certificates, they will automatically be deleted from a related key ring. But if we delete the key ring, the certificates still remain. And so Jim's certificates are still there. You can see the identifier here that says Jim. Even though I'm the owner of the certificate is related to Jim's key ring. I'm going to go ahead and delete that certificate. So now we're back. Now we use two certificates. One is a CA certificate. So we're actually going to use that CA certificate to sign the personal or in-entity certificate that will be used in the signing itself. So I'll delete Jim's auth certificate as well. Okay, so now we have two key rings still remaining and their related certificates, but Jim has been deleted. So now we have to rebuild that. And to do that, we just simply enter Jim's user ID. And we say yes, and we want Jim to be the owner of that particular key ring. So we check LLID and we're good to go. That's all that's really necessary in order to build a key ring that can be used for signing. So down at the bottom, there is an option that says create or update profile a key ring. So we'll go ahead and click that. And you'll see essentially how this works. So we specify what we want to do on the previous panel. Now this one shows us what we're about to do. So from that information, it is now built the RACF commands that need to be issued in order to create the key ring, in order to create the RDataLib profile that's associated with that key ring, and to give us an option to permit Jim to it. So we'll go ahead and do that. He'll have update authority, build the facility class profile that's associated with this key ring, and importantly, build the APPL data component of that profile that defines the key ring that we're about to build. And again, give Jim access to that particular facility class profile. So now we've done everything that needs to be done. We've defined the key ring. We've defined the two profiles, our RDataLib and facility class. We've defined the APPL data component. Really critically important, going back to that callable service we mentioned earlier, that service is first going to interrogate the facility class to see if it can find a profile that matches Jim. If it does, it's going to extract that key ring from that profile, that APPL data component, match it to the key ring and the facility class, our RDataLib class profile to determine what certificate is actually going to be used. So a lot of moving parts, the shin bone's connected to the knee bone and the knee bone's connected to the thigh bone, back to my anatomy analogy. So I'll go ahead and click add it. Again, trace is turned on. And we can see all the steps and the messages that were issued by RACF telling us, for example, okay, we did it, but it's not going to be reflected until we actually issue a refresh. And we did the refresh. And again, on my UNIX system, no reply was received. When I hit PF3 to get out, the next thing we're going to see is the ring worksheet. And notice here that we now have 3 rings. Jim's key ring is back, the one that I deleted earlier, but it doesn't have any certificates connected to it. And so we're going to have to go and make some certificates in order to complete this process. So I'll go back. So now I'm back in my main panel for constructing the various structures that are necessary. We built a key ring. The key ring's still loaded in the panel, so we don't have to enter anything more at this point. What we have to do now is build the certificates that will be attached to that key ring. Now, by default, in Valboot, the name of the certificate that's used as the CA certificate and the name of the certificate that's used as a personal or signing certificate are defined. Valboot CA, Valboot SG. What you can do is assign to it a suffix. And our recommendation is that you use a suffix that in some way will relate to the signer, Jim in this case, and a specific KEC that's going to use those certificates so that at some later point it becomes obvious if you look natively at a certificate list that you'll be able to spot the certificates that are being used by Jim to sign resources for a specific KEC. So I just, for purposes here, will put in Jim, CEC, and that's, we'll identify it to that particular KEC. Let's put it 1. Now, the suffix that's used here has to be the same as the suffix that's used here. Okay. The reason for that is because we are using 2 certificates. One is the CA certificate and the other as the signing certificate that's signed with the CA certificate. At some point in the future, if we were to renew the signing certificate because it had expired, then we would need to know at that point, without having to go through the complexity of adding and deleting and all those kinds of things, what was the name of the CA certificate that was used to sign it? And this is the link that's necessary in order to make that happen. In order to complete the subject signing name for these guys, we're going to just assign Jim name. And this could be different. And some organizational name. Again, these could be different. I just make them the same because it makes it easier on me. I think if you work with this a while, because it's easy to build these, delete them, build them again, delete them, look at them, see what they're doing, figure out all of that stuff in your head. Once you get a pattern, then I would recommend that you use that pattern if it's one that you understand. Notice the various options on the far right-hand side. Our CA certificate will have a life of 5 years. It's in a country called the US. We can overtype any of these values. The signing certificate has a life of 1 year. You could change it to 2, 3, 5, whatever. I don't recommend that. I think they should be short duration. Signing certificates themselves are subject to renewal. And then again, another country. All of that is going to be put together in order to create the subject common name. They can all be the same because, as you notice here, there is, by default, component of that subject name, the title, if you would, the val boot cert auth and val boot signing, that will differentiate them. And again, you can overtype that if you want to, but again, it's really no reason to do that. This will keep it identified for you should you need to query the subject name at some future point in time, a function that's available within our certificate intelligence tool. So if I click on create, update, and connect certificates, we're going to go ahead again and we're going to lay out the commands that need to be issued in order to create those certificates, and again display the key ring that those certificates are going to be attached to. Now, you can see some of the characteristics that are recommended as a best practice by IBM, and there are references at the end of this presentation that detail all of these practices that you probably will want to review. The first thing to note is that both of these are going to be stored, their private keys are going to be stored in the PKDS, and they have fairly significant size for the CA certificate, which will be 4096. So everything's here, it's all laid out. You can review it, get familiar with it. Again, like I said, you can create these, delete them, create them, delete them without harming anything in order to experiment with the process itself. When we hit enter, we'll go through the process of creating both certificates. Now, as I mentioned, this CA certificate is quite large, 496. That's by default. There's no way for you to change that. Again, it's a recommended best practice. The actual signing certificate is actually much smaller, 521. We are finished with the process itself. It took a couple of seconds to make it happen. Here's our trace again. If we page down, we see similar notations. Typically, the messages that are in here, if there are no conflicts, show that everything is okay. They won't take effect until we actually issue a ZROps refresh. You might find messages in here that say something like certificate already exists. You forgot to delete it. You can't add it again. It won't allow you to do that. It possibly might say that someone doesn't have appropriate authority to add a certificate. That just whatever RACF would normally issue as a message, you will find that in this trace. But generally speaking, if you follow the steps in the regimen that we recommend, then the certificates will be created. If I PF3, the next thing we're going to see is the key ring itself and all the certificates that were created to attach to that key ring. So the key ring was there from step one that we took. The certificates were built again in step two, and they were attached to that key ring, and they are now available for us to use. And so what we've seen so far is the ability to be able to delete a key ring, delete the certificates that are associated with a key ring, and to rebuild it and attach those certificates back to it. So I'll PF3 back. And now we're going to go to the management structures here. We'll look at the val boot structures. We know we have a key ring out there now, which is associated with JLOT1, and we'll go ahead and use it. Now, I'll put the cursor under JLOT1 because this is where we're testing now. We're testing to see if the structure that we built is going to work. Now, I'm the owner of this session, and I am the one who is going to submit the IEW sign and ICQDF jobs that are going to be used to sign these resources. But the actual owner of the certificates, or excuse me, the key ring itself is the signer. In this case, it's JLOT1. So in order to do that, I, as an administrator, am going to have surrogate ability to submit a job on Jim's behalf. Now, there are circumstances and organizations where surrogate responsibility is not generally available. To do what I'm about to do, you would have to have that, but you don't actually need it. You could create these for Jim. Jim could go test them on his own if you set him up as a signer to make sure that these signing components can take place the way you expect. So I'm going to go ahead and select just a test sys1.svclib component that I have available here. And you can see it's relatively small. It only has 4 modules in it. I check it. I go ahead and sign it. Now we have an option to sign in place, and I'll come back and do that in just a moment. The first thing that we're going to do is we're going to display the JCL that's going to be used to submit the job that's going to do the signing. So you can see the user that's associated with the job is JLOT1. You can see the end file, or the source file, is sys1.svclib. And by default, in this case, because we're not signing in place, an output file which contains my user ID, prob1, a defined qualifier called valboot signing, and then the name of the resource itself. When I hit PF3, it will come back and give me an option to either can out or keep going. So if I say yes, I keep going. So it's running the job, waiting for it to finish. And when it does, it comes back and it shows us what the output of the job actually is. Now, at this point, I breathe easier, and I'm sure you will too, when you see this, successful. So what it's telling us, module by module, and I page down here just a little bit, is that each of the 4 modules that were in that source library have been signed successfully. And that's what we're looking for. And what's that telling us is that the structures that we set up, the key rings, the certificates, the profiles, and the permits that are all associated with Jim and his key ring have functioned as expected and can be used for signing load libraries using IEW sign. Now, at this point, that may be all you need to know. And you may go off on your own and have your own IEW sign job or whatever. And God bless you, that would be an appropriate thing to do. But if you ran that job and it failed, I guarantee you that there's not enough information in here to be able to tell you why it failed or when it failed or who failed it. There'll be a return code 4 or return code 16 that will simply say can't identify the appropriate profile, or the profile didn't work because the key ring was messed up. There's a number of them, but there's just simply not enough information to make it work correct, to diagnose what went wrong. On the other hand, if that happened here, what you could do is ask it for more information. And the way in which you would do that is by running a report that will allow you to gain some insight into what might have taken place that prevented the signing from taking place. Now, in our case, the signing was successful, so we're running a report that will prove its success, if you would. This is, we could think of as an audit report. Again, we're running the job IEW sign, and this time the PARM action is report and not sign as it was in the first case. So we'll run it again. Now what we're doing is we're taking a look at what was signed, and we're extracting from it some key information, the subject key ID and the certificate fingerprint, critically important. But still, even at this point, we don't know exactly what key ring and certificate were used in the signing process. We have the fingerprint, but we don't know how that fingerprint relates to a specific certificate. So when we hit PF3, it'll ask us if we want the details. And if we do, we just hit enter. And now what we've done is we've matched that fingerprint against the certificates that are in the RACF data store and now pulled back the certificate that matches that particular fingerprint. And here's all the signing details that are associated with it, including the key rings, the profiles, the connected certificates, the PKDS label metadata, its attributes, and its security profile. All the things that we built when we were building the structures themselves. Those are all now related and made available to us. If we're happy with that, then in our next step, we would want to export the certificate to a data set and make that data set then available to our friends at the HMC so that they could import it into the HMC in order to use it for validation during a Z-boot loader IPL. You can see we highlight the expiration date to make sure that there isn't something that needs to be paid attention to. You can change some of these parameters if you want to, the name of the data set, the registry date and time information. We keep a registry of all exports if you want to do that. But when we click Export Certificate, we'll show you what is actually going to be in the export data set itself. So here's the certificate that will be imported into the HMC. All of its gory coded content. When we hit PF3, it'll give us exactly what that looks like. So instead of, it's an option here now if you want to do this, instead of just exporting that certificate and allowing it to be imported on its own, you could accompany it with this particular data set as well, because it will give our HMC friends the information that they need in order to understand what it is they actually received. What was the source library that we were dealing with? What was the target library? If it was signed, and that would be more relevant if we were signing in place. Who signed it? What certificate? What's the export data set itself? Was there a private key? Was it trusted? What was the date? All of the gory detail that they might be interested in. Excuse me. Even down to the certificate itself. So now there's an ability to not only send them the certificate, but to accompany it with a report that allows them to understand in more detail who signed it and with what, and perhaps give them more clarification, if you would, of what it is they're about to import into the HMC for the signing process itself. PF3 out, it'll ask us if we want to post this summary to the control journal. We'll say yes. Here's the summary. And then it will come back and it'll tell us that, yes, it was posted and it was attributed to the user, not to the persons whose keyring we used for signing the certificates, and signing the resources, but to the individual who's actually performing this task. And so now we're back. We can sign a volume, and there we can line up our volumes down below. I have one sysres 1. If we choose a volume that is not capable of being signed, we'll get a message that says this is a storage volume and it's not allowed to have IPL text on it. So there are a number of different places in Valboot where different options are not appropriate for signing, either initially or later, and messages are displayed that gives you information about that. We're back. We'll sign the sysres volume. So it's asking us if we want to keep going. Yes, we do. And so now we're not running IEW sign, we're running ICK-DSF. You can see that this is being attributed again to Jim. I have surrogate authority to do it. You can see the PARM down here that says this is for a list directed IPL. I'll go ahead and submit it. Ask me if I want to continue. Yes, I do. And process completed. We'll reiterate that by telling us what the return code was. If it was 0, we'll get an option to post it to the control journal, which we will. This is what's going to be posted. And now we're back. So one last thing here. Let's pick one of these. And let's sign it in place. So notice in this case that the in file is the same as the out file. Now, one of the things you have to be careful of when you do that, if you're doing this outside of Valboot, is that when you actually go through this signing process, you have to make sure that the source file, which will also be the out file, has enough space in it in order to accomplish what needs to be done in order to actually sign. And so if you run out of space, you won't get this successful message. You'll get a failed component. We'll just simply go back now and take a look. Everything was fine. If we look at this guy, and we look at the members that are in it, these lines down here at the bottom, these 4 lines are the signing lines. And so as we go forward and sign in place, as we complete the process, there's additional space requirements that are necessary in order to accomplish the signing, because there's additional signing text that's added to the individual members themselves. So when I go back now, when we started this process, I should have pointed it out, this number was actually 15. That is, that the percentage of the allocation that's associated with this particular library was 17%. So I had plenty of room to go ahead and sign it again. But if I sign it, then the usage is going to go up. Now I can unsign it also. So you can see here the action now is unsigned. So it was successful. We can go back. Now you can see that the percentage is 18.7%. So whether we're signing or unsigning, additional space inside of the library is going to be consumed until we could potentially reach a point where we had a situation where we were attempting to sign a library where we had used up to 50% of it previously. If that happened, Talbot would issue a message that says, no, you can't sign that again in place. You are going to run out of space, and therefore the need for being able to perform a test without signing in place. If we look at the modules now, we can see that those 4 lines at the bottom, in fact, have been removed. Okay, just one last quick thing here. We're in the VTAM application that is used to manage and control the interactive use of image focus in the control editor. There is an option here called IPL View. IPL View has an option called Val Boot. You can select that. You can select the type of user you are. If you're an admin, as I am, you'll reach the exact same panel that I've been using under TSO-ISPF. In addition, the TSO-ISPF commands can be used from the command line here if you want to do it. Looking quickly at the work view, if we were to perform an inspection using one of the images that have been defined, again, I'm on a ZPDT, not in a sysplex, I could choose that. And one of my options is to perform a simulation of the validated boot process, as it's referred to here, secure boot. I should bring to mind the idea that there are 3 different names that are often used simultaneously, interchangeably: validated boot, secure boot, list directed IPL. They're all used the same. I like to think of it as a list directed IPL that has 2 components: building the structures, that's validated boot; using the structures, that's secure boot, and both of them are grouped together under list directed IPL. Okay, well, I've used up all of my time here. So let me just go quickly back to sharing something, if I can find it. Oh, there it is. Okay, so we had our look, and I want to make sure that you notice in the copy of this presentation that Sammy is going to send to you, there are some references and resources included. They're all hot linked. Some of them explain why this is important and why it's been gaining momentum over the last 10 years or so after NIAP, the National Information Assurance Partnership, broke off from NIST, which I'm sure you're quite familiar with. What it is they're trying to protect against, supply chain attacks, and some concerns that people have. And then the nitty-gritty resources, the most important of which is this link to a report that was, or a set of documentation that was written by Kevin McKenzie about a year ago that details what validated boot is all about and its best practices. And it's that report that we used as the starting point for the building of validated boot. These other links detail RACF explanation and an understanding of the facility class profile IRR program V2 signing are also critically important to understanding this in detail. And then if you like me, or you like New Era, and you need more of us, then you can go out on YouTube and follow us there as well. If you want any additional information, send an email to Andrew or Sammy at support@newera.com. and/or click a link that you see here for a one-on-one detailed session. Thank you so much for coming out and joining us today. I really appreciate you attending and sharing your day with us. And again, much appreciate your support of New Era and our products. All right, Sammy, we're back to you.
Thank you, Paul. And one more time, thank you everyone for joining us today. As Paul mentioned, I will be following up and sending out an email with the slides. And if you have any questions or would like any additional information, don't be shy to reach back to me. I would be happy to get you anything that we're able to. Thank you so much and have a wonderful day.
Bye-bye.